Okay, so let's do a little bit of review. So the zeros of the function are, so we've been talking about polynomial functions like this for a little bit now. But sometimes I ask the question one way, another time I ask the question another way. So let's put it all on the same page here. So what are the zeros of this function? Negative 2. Perfect. Those are my zeros. What are my factors? Factors are different, or at least in different forms. Exactly. X plus 2, x plus 1, x minus 1, x minus 2, in that order. Because if I were to set each one of those up to 0, right, x plus 2 equal to 0 means x equals negative 2. X plus 1 set up to 0 means x equals negative 1. Yes? No. I would write it completely off, especially at this time with these. Okay. The solutions of the function are, so f of 0, or where f of x is 0, I should say, where f of x equals 0, means I plug in a value for x and I get a 0. What are the solutions? Negative 2, negative 1, positive 1, positive 2. These answers are the same. They are the same. Zeros are the same as solutions. Solutions are the same as zeros. Is this helping a little bit? I mean, it all means the same thing, right? We're all talking about these points on this graph right here, right? We're just describing them in a different manner. And the final one, the x-intercepts of the function are. What are my x-intercepts? Negative 2, 0, negative 1, 0, positive 1, 0, and positive 2, 0. So if I were to ask you for the x-intercepts and you said negative 2, negative 1, 1, and 2, is that correct?
No.
No. You may understand what you're talking about, but you're not saying it in the correct manner. And it does matter, right? Especially since we know that these two mean the same thing but look very different, right? So you've got to be careful. So I just wanted to kind of go over this again with you. Any questions so far? All right, I will be able to determine the number and type of roots for a polynomial equation. That's what we're doing today. So go ahead and write this one down as well. Okay, so our title today is Roots and Zeros. What are the different ways we can discover roots?
Factor.
You can factor. Actually, I want this in blue. All right. What else can we do? Quadratic formula. Give me another one. Graphing. I think grouping goes along with factoring, but you're right, grouping. Completing the square. You guys have learned a lot this year, huh? Completing the square. What else? I heard synthetic. We could call it synthetic substitution. I think that's more accurate. Substitution. That we just did yesterday. One more. Long division. And graphing calculator. No, I'm just joking. But it's true, right? If you want to check your work, put it in the graphing calculator when you're at home. I'm going to show you how to do that with GeoGebra. How many of you know what GeoGebra is? Okay, that answers my question. GeoGebra is a free software that is a graphing system for geometry and algebra. GeoGebra. Okay, what types of roots are we able to find? Two different types. Rational and irrational go underneath an umbrella called real and imaginary. Under real, we have two different, right? What do we have? Rational and irrational. I'm getting the feeling that some people don't know what that means, so let's give some examples of that. So we have rational. What would be an example? Oh, it was so pretty. Rational would be 6, 1, what about 1/2? -2. What would be irrational? No, that would be rational. There you go. Square root 5. 4.3. Excellent. What will be over here in imaginary? Something with, because that keeps going. There's another one.
Oh, I said 2/3 and you said that would be rational. The first thing I said.
Oh, I was thinking, you know, you're absolutely right. Thank you. I was thinking just because it was a fraction. Wasn't catching the whole thirds thing. Very good. You got it. What about this one? Negative root, like -2 or 3i. Okay, there's one more bracket I could put underneath here. Well, integers are in there, bless you. But underneath real, they're either, and this is what we're going to talk about today. Roots are either something we haven't really talked about specifically, positive and negative solutions, which kind of makes sense to have some emphasis on this now, because graphing these polynomial functions with degrees greater than 2 and 3 are pretty rough, right? So if we could talk about what they look like on the positive side of the graph and on the negative side of the graph, that could help us when we're trying to graph them. I say that in the nicest way possible, because this stuff just gets kind of rough. All right. Questions so far? All right, pencils down. Let's just talk about this. Solve each equation, state the number and type of roots. So I kind of put over here a little medley of what we've been doing so far. What do you think I could do with this one? I don't think I'd group it. I could factor out an x. When I factor out an x, I get x squared plus 2 equals 0, which basically says x times x squared plus 2 equals 0. So I already have a solution right now right in front of me, correct? X equals 0. And x squared plus 2 equals 0. I can't factor that any further, right? But I can solve it. Jacob, how would I solve it? Subtract the 2 from both sides, and I would get x squared equals -2. What would I do with that? Take the square root of both sides, and I have x equals plus or minus I root 2. Good. So I have how many real roots? One real root. And how many irrational roots? 2 irrational roots. My one real root is 0. That was nice. And my 2, hey, irrational roots are I root 2 and negative I root 2. I think it's important to write all of them out for the same reason as the fact that half of you said 1. Right? We need to write them out separate so we realize those are 2. Questions? Write those down. Okay, let's go back here and rename this. I know. Sorry, they're imaginary because we have I. Thank you for catching that, Jacob. 2 imaginary roots. I don't know. You'd rather me not record? I don't know if people actually watch it. But people contact me and say, Mrs. Mahler, will you please give me the link because I need to watch your videos. What?
I watch it.
Yeah?
Larry's making it. It's like,
Ready?
that's just every 20 minutes tonight.
And rewatch it?
Yeah.
It might cut your homework time down if you watch it real quick. At least even fast forward through it. Because, like, you know, refresh your brain. Oh, okay, yeah, that's what. Because when you get home, half the time, don't you sit down and do your homework and go, ah, crap. I remember how to do this. It was only like 4 hours ago. Sometimes notes help.
One thing I looked at in my notes.
How much time is it?
Oh, there was a lot.
You ready for the first step? Okay, 5, 4, 3. You ready for the fun stuff? What? Oh, okay. That's good. Accountability is always good. Ready? No?
Yes.
Ready, Justin? Yeah? Okay. All right, let's look at the similarities here. So I forgot to go back over this one. I have real solutions and imaginary solutions. What are my real solutions? 2 and what are my imaginary solutions? And negative 2i. What about on this one? How come there's only 3 here? See the degree of the polynomial? See the degree of the polynomial? See the degree of the polynomial? There's going to be 5 roots. Now when there's 5 roots, there's something that we call Descartes' rule, which helps us figure out which direction the roots are going. Because if I were to graph this, you'd have positive roots and you'd have negative roots, right? So Descartes' rule tells us how many positives we have and how many negatives we have. Okay, so this is how we find it. Just watch me and listen. You're going to have plenty of time to copy down. Just copying down my entire problem, and this is what I'm going to do. Sign change? No. Sign change? Sign change? Sign change? Sign change. Because there are 2 sign changes, there are possibly 2 real zeros. But not for sure. Either 2, or you can lessen that amount by an even number. Sounds a little complicated. So that would be either 2 or 0. Those are our possibilities right now. Okay? So for instance, if I said there are 4 zeros or less, it could only be 4 or 2 or 0. What if I said there were 3? 3 or 1, right? You can only count by 2s. Okay? Okay so far? All right, so that's in the positive direction. We still need to account for the negative direction, so let's make x negative. So 2 times negative x to the 5th. I'm just going to take each one of these terms and make x negative. Plus negative x to the 4th plus 3 times negative x cubed minus 4 times negative x squared minus negative x plus 9. So this was f of x in the positive direction, or I should say h of x, doesn't really matter, and f of negative x, negative direction. Let's talk about sign changes. Oh, got to evaluate first. What is a negative odd number of times? Still negative, correct? And a negative an even number of times? Positive. Odd number of times? Negative. This one, which still makes it negative. Positive. Positive. Let's talk about sign changes. Sign change? Sign change? Sign change? Sign change? Sign change? So we have possibly 3 real zeros in the negative direction for a total of, let me move this over. This is where everybody in second period got mad at me. For a total of how many? 5. Or a total of 5. For a total of 5. Let's talk about our possibilities. 2 in the positive direction and 3 in the negative direction means I don't have any 0 or imaginaries for a total of 5. 0 positive in the positive direction. What's 3 minus 2? How many, if I had 1 negative real 0, where did I get the 2 from? Here? Because there was 2 sign changes in the positive direction. So I can have 2 positive real zeros. I'm gonna put a picture to it in a second, okay? Number of imaginary zeros. I can't have any imaginary because they're already taken up. If I had, in theory, if I had 2 in the positive direction and 3 in the negative, are there any left over to be imaginary? No. If I had 0 positive and 1 negative, how many would be left that were imaginary? There's one other possibility. There can't be because we know about the sign changes. Because there are 3 sign changes here in the negative direction. That makes either 3 or 1, but since I've got a 2 and 3 and 0, here I have a 0 and 1. Did I ever talk about having 0 positive and 3 negative? Never talked about that. That's a possibility, right? These are the most complicated ones. Let's do something that's a lot less complicated. Now from here, okay, so the whole point of doing this is to be able to start using synthetic division, because I can't, can I factor that? Can I group it? Can I graph? I guess I could start graphing. Or I could use what we did yesterday, which is synthetic division. But wouldn't it help to know which direction I'm going to go in and when to stop looking? You know what I mean? So if I start going in the positive direction and I go about 4 out and I start getting really huge numbers, is there ever going to be a real 0 in that direction? No, that's what this is telling me. It's saying if you're going in this direction and you start putting in numbers in synthetic division and the numbers start getting really big, well, I guess there aren't any over there. Jacob? Yes, it's exactly what it is. It's a generalization of where you're going to be, where you're going. It works better when the numbers aren't that big. Okay, so if I'm going in the negative direction, I'm either going to have 3 roots, and I'm probably going to find them pretty quickly, or there's 1. Now, I started doing this using synthetic division, and it got really, really ugly, and I'm going to show you why. You want to see a secret? I put it in GeoGebra, and this is what I got. It is crazy, huh? So how many positive roots do I have? Positive real roots? None. How many negative real roots do I have? 1, but look it, I couldn't even find it with synthetic division. It's not imaginary, it's irrational, right? Can I find irrational roots? So that's why this would be a really frustrating problem to do using synthetic division. But at least I'd know, hey, this one's really hard. And then that's when I would use a tool like this to say, there's got to be something weird going on about this. Yeah, probably would not be on the test. So I've got imaginary roots up here. Okay, how many do I have? 4. Why do I have 4 imaginary roots? Because I only have 1 real root, so I must have 4 imaginary roots because my polynomial is to the degree of 5. Okay, let's go back and copy this down. Thank you. Okay, let's move on. Try this one. Can you guys do it on your own? This part of it at least, the table? Okay, try the table on your own. I'll do it quietly as you guys are doing it, yes? Any sign changes in the positive direction? Nope. So there are no roots in the positive direction on this one. That's helpful, right? When you're using synthetic division, isn't that helpful? You don't even have to go, you've eliminated all positive roots. I think that's very helpful. Look at the negative. I've got how many sign changes in this direction? 3, right? I did it right, correct? Everybody got the same thing? So 3. So I have a possibility of 3 in the negative directions, or what? Not 0. 1, right? Increments of 2. Because you have to go down 2. If you think about it, I'm applying a negative. Let's see how well I can explain this. You can't go down to 2 real zeros because that would make it positive, right? You know what I'm saying? Because we applied a negative. So if you're talking about every negative, you're talking about every other, every other, every other. We already covered all of them in the positive direction. There's none of them. So in the negative direction, there's either 3 or 1. So there's a total of how many roots? 3. So if there's a total of 3, if there was 3 negative, there would be 0 imaginary. If there was 1 negative, there would be 2 imaginary. All right, make sure you have this copied down, and then I'm going to go further. Okay, so let's copy this down. I'm going to copy the next screen. I'm going to erase this part because I don't need it anymore. And let's start with, so what would you use in the negative direction? Negative 1, 1, 2, 9, 18. So negative 1, 1, negative 1. Is this going to work?
Why did you choose negative 1?
Because we know we could have 3 in the negative direction. So let's start with negative 1.
Oh, we can go up to negative 3.
No. Okay, let's back up. Here's a graph.
Oh.
I have none in the positive direction. None. So I'm going in the negative direction now. So negative 1, is this going to work out? No. So what would I go to next? I would go with negative 2. This happens quickly. You ready? 1, negative 2, which is 0, which is 0, which is 9. It's going to work. My life just got a lot easier because I just found a root. So if my root is negative 2, what would my factor look like? X plus 2 times x squared plus 9.
Why?
See it? You don't really need this part, right? You don't really need it because you already know that one of your roots is negative 2. What's the other root? X squared equals negative 9. So x equals plus or minus 3i.
Where did you get the x squared plus 9 from?
Right here. X squared plus 0x plus 9.
Right.
So once I found one root, the rest was piece of cake. Does this make sense? 1 negative root and 2 imaginary roots? Absolutely. Yes. You know what you're supposed to do, Justin? Practice them. You know when you're supposed to practice them? Homework. So if you don't practice these in homework, do you think you're going to be able to fish this out of the sky real easily? No, probably not. Probably takes it. If you don't really have time to fish, because I'm not going to give you guys any more time on tests. Okay? We talked about that, but I'm not going to anymore. Okay. Questions? Yay. Okay. What did you learn today?
How to find out the general. How to find out
the zeros, right? How to estimate the number of zeros. Not really estimate. Well, I guess it is. We're still kind of estimating. What does Descartes' rule provide for us? The number of positive and negative roots and imaginary roots. The person next to you is absent. How would you explain how to find how many real and imaginary roots you have?
Look at the power of the polynomial.
Which is called the
Power.
degree. On your assignment sheet, the blank of the polynomial tells me how many roots I need to find. Good, the degree. Good job, guys.